Okay, hello Chem AP students. I'm Mr. Hevel,
And Mr. Moore.
and today we're here so that we can videotape your first lab. Okay, but we got to give you some background so you have an idea what's going on. So, I believe this reaction that you're going to use involves a double replacement reaction.
Double replacement reaction. You remember what that is?
If you don't, go look it up. Okay, and because we're going to make a precipitate for this reaction, we can capture the precipitate on a piece of filter paper. All right, and we have to show you a new lab technique that we use to help that along. Okay, so the College Board would refer to this as gravitometric analysis. Okay, we're going to use the mass of the precipitate to help us calculate something.
Sounds good. Yep. So what kind of equipment do we have for gravimetric analysis?
Yeah.
We have one of these. A normal flask is not quite normal. It has this sidearm on it. So you can, we'll do something with that. There's going to be a funnel that has a stopper that it's going through so that we can make a good seal between the funnel and the inside of the flask.
And we have a piece of filter paper, again, that will be in the funnel to capture our precipitate. And if we did this using gravity to pull the water through, it would take a long time. And Mr. Moore has a lot of patience. I couldn't wait that long. So we're going to use something called suction filtration.
Yep.
And I don't know if they can see it because we're a long ways away.
Yeah.
On the faucet, there's a device called an aspirator. And it's what's going to generate the suction force. So let me just show you real quick what's going on there. So if we turn the water on, the water rushes through the nozzle, but it pulls air through this sidearm. And you can tell that because when I plug it up, the water slows down. Okay? So the idea is we're going to hook this heavy-walled vacuum tubing up to this sidearm, and we'll connect it to the flask.
So that creates a vacuum? That's pretty cool.
Yeah, here, we'll check it out. Here, let me take the funnel off for a second.
Yep.
If I turn the aspirator on, put my hand over it.
I can hear it. Yeah. Oh, how nice.
Yeah, you hear the popping noise? Yeah. So we can generate vacuum, and that will help draw the water through so we don't have to wait as long.
Doesn't that waste a lot of water, Mr. Hevel? What about the fishies?
Well, you know, it all goes back to the same place. It's going to go down the drain
Oh, okay.
and go out to the lake.
Okay. All right.
And chemistry is more important than anything. So
Absolutely it is.
the fish will figure it out. Okay. So let's show you what a difference it makes, though. And I wish you were here live to be able to do this, but we have to put the piece of filter paper in the funnel and get it to seal tightly. And so we'll fold it in half once, fold it in half twice, and if we pull 3 of the 4 edges together, we get a nice cone shape, and that'll fit inside that funnel tightly. So normally what I do,
We use a little water to help
go.
that stick. We wish you were here for
Yeah.
this. You need to be doing all this yourself.
yeah. So usually I soak the filter paper down and I press it tightly into the funnel. We want a good seal. We don't want any air rushing behind the filter paper because then we lose suction power. So if I put some water in here, okay, I don't know if you can see this. The water dripping through. I don't know how well it's showing up. If I put my hand back there. Can you see the water drips coming through? Notice the rate they come through. It's not real quick, and once you get precipitate on the paper, it starts to plug it up, which slows it way down. But now watch, I'll turn on the vacuum.
Wow,
And all of a sudden, pow, the water just gets pulled right through. Okay, it speeds things up quite a bit. Okay, so that's suction filtration. We're using this technique to help us capture the precipitate that the reaction generates.
And it goes a lot faster with the suction.
Yeah.
We can't stress that enough. We would be
Yes.
sitting here for a
For a
long time. Yep.
Yes, it would not be good. Okay. So let us tell you some more information. What, did we forget anything there?
I think, no, that's going to get us our precipitate, and we'll filter everything that's dissolved right through the paper. The paper
Yes.
only catches the solid
I did say that.
precipitate, and everything else goes through.
Right, anything that's aqueous runs through the paper.
Yep.
Yep.
So should we talk
Yeah.
about the specific lab?
Yeah.
All right.
You want to stand or you're just gonna?
No, I'm just going to hold it.
Okay, so there's a little bit of information you need. Last year, we used solubility a little bit, but it's important to know this. These ions are always soluble. Group 1 metals, the ammonium ion, and the nitrate ion. You need to know that, okay? Here's what you're going to get. You'll see this in a minute. We mixed 2 ionic compounds together. There's potassium chromate and barium chloride, right? They're both solids. We mixed them together to create the sample, okay? Another very important item to know is that potassium ions, barium ions, and chloride ions are all colorless in solution. But the chromate ion looks yellow. It's a very noticeable yellow color if it's present in solution. Okay? So what's going to happen here, and you'll see this in a minute, we have a sample that has these 2 solids on a piece of paper, okay? Essentially, we're going to dissolve it in some water. The double replacement reaction will happen. A precipitate will form, and then we're going to filter out that precipitate. Okay?
Yeah, double replacement, remember, the positive ions switch places.
Something like that. I get confused.
Yeah.
Yeah.
I'm just trying to work that out in my head.
Yeah. I mean, you haven't done this in a year, so.
It's been a long
I
time.
forget,
Yeah. Okay. So that's what we're up to. Let's see. There's already a sample that has been measured out
Yes,
and
there
waiting
is.
for us.
Yep. Normally, if you were here, you would get every lab group would get his very own sample to use. And so, Mr. Moore and I are the lab group now.
We'll see how we can botch this up
Yeah.
for you.
Oh, and we will. Okay. So here's the sample. I don't know how well it shows up at all. Not this way. So on a piece of paper.
Yeah, you know what? I can tilt this down. See it.
Yeah. I think, oh, now we have a ton of glare. You
Okay.
can't see anything, I don't think.
Ah,
Okay.
there it is.
There
There's
you
the
go.
sample.
Okay, there's the sample. Okay, again, it's the potassium chromate and barium chloride mixed together on this piece of paper. Okay? Now, it's probably important for us to know the mass of this sample to start with.
Yeah, we
Okay?
probably ought to know that.
Probably ought to know that. So we got a balance here, a scale.
We're going to dissolve that sample in water, so we'll use a beaker. We'll put the beaker on the balance.
Should we move it over
Yep,
closer?
I'll bring it over.
I can move this.
That's all right. Well, I'll need to pick this up to be able to see the mass on there.
Oh, I guess so. Okay, so here's the beaker.
Yep.
You
That
use
mass doesn't matter so much. We'll just zero out the balance.
Okay, so here we go. We're going to add the sample to the beaker.
Yep. And the mass is
Get the mass recorded. That's important.
now we'll dissolve that sample.
Yep. Put a little water in here.
Both the reactants are soluble, so they dissolve, but then there's a combination of ions that's in there that's going to not dissolve.
Right. Remember, this reaction occurs in aqueous solution. And hopefully you can see that it's cloudy.
Mm-hmm.
There's definitely precipitate in there. And again, gravitometric analysis is all about capturing that precipitate and then using that mass to help us calculate something. Should be dissolved, I would think, by now. Just a dash of water.
Yeah, when you're doing this yourself, you have to be careful. You don't want to fill up the whole beaker with water because you eventually have to filter all of it out.
Right. Not fun. Okay, so here we go. We'll have to rig up our filtering apparatus.
Oh, did you measure the mass of that filter
Do you
paper?
think it's important, Mr. Moore?
Yeah, we should do it just for kicks.
Okay, all right, just for okay.
All right.
Got it?
Got a mass of the filter paper.
Okay, might be important. Okay, so we already showed you doing this once, but we're folding up our filter paper, place it in our funnel. I'll dampen it up. You want it to stick to the funnel very well. Okay, and again, you can see if you're relying on gravity to pull the water through, it's not a real quick process.
Yep.
Okay. Okay, let me turn on the water.
Yep. We'll suck that water out of there.
Okay, now we should be ready to filter. I got a good tight seal. And away we go.
I'm trying to move the camera so I don't have so much glare. There's a lot.
Yeah.
Oh, that's even worse.
I wonder if we turn off the lights.
Yeah,
backlights.
well, you can see it well enough, though. I mean, you got this cloudy solution.
Yep.
Look at that, that's coming out. Nice, clear solution because it's trapping all of the precipitate inside the paper.
So we're trying to be careful. We don't want to fill the funnel up above the top of the filter paper. That's a classic mistake because some of the precipitate will run behind. And you notice how much it's slowing down, just so far even, because the precipitate plugs up the pores in the paper.
Mm-hmm.
If we were waiting for gravity to do this, it would be painful.
Yep. Okay, so you see the process. We'll come back when we're just about done with the contents of the beaker. You can see there's quite a bit left there in the beaker. And then we'll want to rinse it out with a little more water and try to get that solid off the sides.
Yep, really, the quality of your answer depends on getting all the precipitate
Right.
onto the filter paper.
Here we're finishing off the last little bit of trying to filter the precipitate out. You see Mr. Hevel's using that rubber policeman to scrape as much of that solid out as we can get.
I used the wash bottle to wash the beaker a little bit.
It is a precipitate, so it's insoluble, does not wash out very well. Doesn't wash out at all. So we really have to work at it to try to get it all out.
Right.
We want to make sure that we don't, that glare is terrible. We don't want that liquid to be up over the filter paper that's in there either. Sometimes we'll see students do that. They'll pour the liquid in all the way to the top of the funnel. Some of the precipitate then will run down behind the filter paper. So we're trying to be careful not to do that. It's still dripping through. It's going slowly now because even though it's got suction on it, a lot of those pores in the filter paper are clogged up now with precipitate. Yep.
Okay, so we're pretty much, being very close to done filtering. I've Use the rubber policeman and the wash bottle to get all the precipitate rinsed out of the beaker and into the funnel with the filter paper. And one thing that's very important to note here is this is called the Filtrate. Down here, the fluid that's gone through the filter paper. Take a good look at what color it is.
Yep, you want to remember this.
Yes. So we'll wait for it to finish going through, and then we'll put it out to dry over the weekend. On Monday, we'll be able to finish up.
Here's our sample in the filter paper 3 days later. It's now Monday. And there's our precipitate that's made a thin coating on the filter paper. I'm going to go ahead and take the mass of it. Here's our balance. Read 0 right now. The filter paper doesn't need to be flattened out. It can just sit like that with the precipitate on it. There's our final mass.